Everybody, this is your first, your review on Canvas for uh, the beginning of trigonometry. We're going to do a couple of different things. The first step for any triangle is to identify your reference angle and your sides, whether they're adjacent, opposite, hypotenuse. A lot of people have been having trouble with this, and I don't understand where the problem is, but hopefully this will clear it up. We're interested in angle x. We want to find the measure of angle x, and we know two sides of a right triangle. And I'm going to mark angle x. This is my reference angle. I'm going to give it a couple of little marks there so you can see it good. Now, based on this angle, I'm going to identify my sides. Now, the side that's easy is the side that's opposite the right angle. In a right triangle, your longest side is always the hypotenuse. It's this one over here. This right angle points at it. This is the hypotenuse, HYP for short. That is the hypotenuse. Now, this is the angle, the reference angle. Now, it depends on which angle you're looking at. For this angle, this is the opposite side, of course, because it's across from the angle. If I were talking about angle Y, this one would be the opposite side. But as it is, I'm interested in angle X. So this is my opposite side, and the only one left is the adjacent. Now, what you have to be careful of is to not get the adjacent and the hypotenuse confused. But the right angle should tell you. The adjacent side is always between the right angle and the angle of interest, the reference angle. Now I'm going to decide which of sine, cosine, or tangent I'm going to use. This is sine is opposite over hypotenuse. Cosine is, that's A, adjacent over hypotenuse. And tangent is opposite over adjacent. And looking at what I know the hypotenuse, and I know the adjacent. So think about which one you're going to use. And of course, this is cosine. So I'm going to write out cosine of angle x. Sine, cosine, and tangent depend on a reference angle. So you need to really write them with an angle with them. Angle x is equal to the adjacent over the hypotenuse. That's what this says. Cosine is adjacent over hypotenuse. That is the A and the H that we're looking at. Well, I'm going to go ahead and rewrite it. Cosine of angle x is equal to the adjacent side is 28 and the hypotenuse is 83. 28 over 83. Now, I have a bunch of ways of dealing with this. One way is to get an estimated decimal for this and then look it up on my table. So I want to look up the angle that has the cosine that I get when I divide these two numbers. 28 divided by 83, I'm going to grab my calculator. 28 divided by 83 is 0.337. And what I'm going to do is a thing called the inverse cosine. The inverse cosine, I'm putting it in red so you can see it. Hopefully you can see it well. You know what? I'm doing blue. Blue tends to show up better on this camera. Cosine inverse is to look up the angle that has a given fraction or a given decimal. So I'm going to look up the angle that has this decimal right here under cosine. So I'm going to grab my table, and I'm going to look in my table, and I'm looking under cosine in this column, and I want to find 0.337. And you should do this too, so that you can learn how to do it. Now, the cosine starts out big, and it seems to be going down, and it goes down to 0.707 at 45 degrees. Not far enough. I'm going to go a little further. Cosine of 0.337 is going to be right about, remember, it's going down, and it looks like, got to look here, it's between these two. It's between 70 and 71 degrees. And it looks like it's a lot closer. This is almost 0.33. And if I rounded this, it would be 0.34. And if I rounded this, it would be 0.34. So it's really close to 70 degrees. That means that my angle X is really close to 70 degrees. Now, I want to get it a little more accurate. And the way to do that is with a calculator. So I'm going to grab my calculator, and I'm going to do inverse cosine. Now, cosine will tell me the decimal that goes with the angle. But I want the angle that goes with the decimal. So I'm going to do the inverse operation. That has a little -1 above it. Inverse cosine of that decimal, or I could just put in the fraction, divided by 83. I could type in the decimal, or I could put in the fraction, and this is the inverse cosine, 70.28 degrees. This is actually accurate all the way out to that 1, assuming that the sides are accurate. So 70 point, this is 28, so I'm going to round it to 0.3 degrees. And there you go. A lot of explanation. I won't go into so much detail on the others. This one I may need to a little bit. This is number 2. And what we have here is we have an angle. This is our reference angle. And I know this is my reference angle. It is a right triangle. It has to be a right triangle. Trig doesn't really work with other kinds of triangles, just right triangles. My right angle points at my hypotenuse. And that happens to be what I'm looking for. Now, they didn't specify on the triangle they were looking for AB, but they asked for what is AB, which is the distance between these 2 points. One way to write the sides of a triangle correctly is to identify them with a single little letter that goes with the letter of the angle. And it has to do with the fact that the opposite sides are related in the same way as the angle that are across from them. So here we go. Here's the one I want to find, which is the hypotenuse. C is pointing at little c, which is the hypotenuse. And think about it before you get confused. Here's my reference angle. Look at the side and decide which side you're looking at. This is the opposite side over here. Now, think about which one you want. So, ka, or toa. For these two, I want either sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, or tangent is opposite over adjacent. And clearly, I'm looking at opposite and hypotenuse, which is this one right here. That is sine. Sine of the reference angle, 41 degrees, is equal to opposite over hypotenuse. Now, in this particular problem, this is a 9, by the way, we've got a problem because the c, or the thing we want to solve for, is in the denominator. And the way you've got to deal with this is you have to multiply by this variable on both sides. It'll eliminate that variable in the denominator. Now, I generally do this in another color. I got to recommend that. I'm going to multiply by c on both sides. Now, remember, this is just a decimal that goes with the sign of 41. The c's cancel out, and this decimal, I can look it up, sine of 41. So I'm going to look in my table under sine of 41 degrees, and it is right here, 0.656. Hopefully this shows up in my camera. And 41 degrees for sine is right there, 0.656. That's the approximate value. 0.656 is the sine of 41. I'm replacing that. Now it's still being multiplied by this c, and it's equal to 9. Now I'm going to divide by the decimal on both sides. And again, I'm putting my work in another color so you can see what I'm doing. I'm going to divide by 0.656. When you divide by a decimal less than 1, the number gets bigger. C is going to be bigger than 9, and we're going to get an estimate here. So I'm going to take 9 and divide it by 0.656. And I get about 13.7. One of my students got very confused. He said, but aren't we looking for AB? And I just need you to understand, C is the length of AB. It's the same thing. So AB is 13.7. And we're just using generic units. We don't put our units on there. Now, if you're solving for a real problem, you really need to put the units, or risk me putting in, cats or dogs or something funny. All right. Now we're going to speed this up a little bit, and you should be working ahead of me. Now we want to find DF this time. DF is this side over here, and using what I told you before, here's the angle E, which is across from the side E. So I'm going to call it little e. I could have just called it DF. It doesn't matter. The important thing is to identify your reference angle and identify your sides. You should be doing this. Now be careful. This triangle is written upside down. This is the right angle, and it's pointing at the hypotenuse. And of course, this is the adjacent. And hopefully you know now that cosine is adjacent over hypotenuse. Now we've got an easy one. The cosine of my reference angle, 23, is adjacent E over hypotenuse, 27.3. Now, a few people have turned their brain off and they just want to do what I did up here. No, I want to get E by itself. That means I have to do the opposite of whatever's happening to E. E is being divided by 27.3, so I have to multiply by 27.3. Notice how different number 2 and number 3 are. This time I'm taking 27.3 and I'm multiplying it by the cosine of 23. I'm going to look up the cosine of 23. I'll do it on the table again. Cosine of 23 degrees is right down here, and it happens to be 0.921. 0.921 is the cosine of 23. And that's being multiplied by the 27.3. And that's going to give me my approximate value for E. The whole point was to cancel these out. And E, which is also DF, same thing, I'm just going to multiply these guys together. 27.3 times, I'm sure hoping this shows up on my video for you, 0.921, and we've got 25.1. Again, units, just units, 25.1. Now, to kind of look at it and see if it makes sense, remember the hypotenuse has to be the longest side. And that makes sense because it sure looks like this is the small side. This side looks like it's almost the same size as this one. But because this is the right angle and this is the hypotenuse, we know this one's bigger. Things to think about. All right, hopefully we can go a little faster now. I really don't want to spend all day at this. Now, number 4, we've got a reference angle, and we have a side, the opposite side. Notice that this is across from the reference angle. And what do we want to find? RT. TR, or RT, is this side over here. Again, I'm going to call it little s, just to be consistent here. You could have called it X or Y. It doesn't matter. I'm just trying to make it consistent. Now, this is my adjacent side. I know opposite and adjacent are on the right angle. The right angle is across from the hypotenuse. There you go. Now, 63 degrees is, and I have opposite and adjacent, excuse me. Opposite over adjacent is going to be so, ka, or toa, decide. And of course, we're looking at this one. Now, I'm going to do something a little different, and I'm going to do it on purpose because I'm going to make it easier for you. something you want to keep in mind is that if this is 90 degrees, the angles inside of a triangle add up to 180. So what I know is that these two angles have to also add up to 90. 90 plus 90 more for these two makes 180. We say that the acute, these are the acute angles, in a right triangle are complements. Complements mean they add up to 90 degrees. Now, hopefully in your head, you can subtract 90 minus 63 and get the 27 degrees. Now, I want you to think about why I might want to choose this one for my reference angle instead of this one. And if you really think about it, you'll figure it out. I'm going to use this would now be, and I should color code it, if this is my reference angle, this one is now the opposite, and this one is now the adjacent. Now, why would I do such a thing? Think about why. I've got tangent of 27 is equal to S over 14. Could I have done it the other way? Certainly. And you're certainly welcome to do it the other direction. I could have used tangent of 63, but then my S would have been in the denominator. Something else to consider. Opposite and adjacent changes when you change the angle. So the complements have reciprocals of one another. Lots of information there. Anyway, tangent of 27. Here we go. Nothing like going off on a tangent. Tangent of 27 is 0.510. There it is, 0.510. And it's equal to S over 14. And I'm just going to multiply by the 14 on both sides. That's why I did that. Looks like it's really close to 7, doesn't it? And you can multiply this. I'm just multiplying 0.5 in my head. Of course, it's going to be a little bit bigger than that because of the 1 there, where we've got 0.51 times 14. And of course, we get 7.14. I could put the 1, 4, or I could put the 1. And of course, this was also called S. All right, I'm sorry I'm taking so long on this. I just want to make sure that it's clear, and I may let you skip ahead. We'll see. All right, we've got a reference angle. We've got a side. We've got a hypotenuse. Here's my hypotenuse. And you have to decide, is it so, ka, or toa? And opposite and hypotenuse is sine. This is sine. This is cosine. This is tangent. I want sine of x degrees is equal to opposite over hypotenuse. Hopefully you know that that is red. 57 over 100, or 57 hundredths, is this. Remember the decimals when you read them? This is 5/10, this is 57 hundredths. Anyway, there it is. I could use a calculator, but I'm hoping you won't. I'm going to look up the angle that has a decimal of 0.57. That is called taking the inverse sine. And I could use my calculator, or I could look it up in the table. Let's take a look in the table under sine. I'll put it in red. There's my red, and I want 0.57. So I'm looking for 0.57. It is right about here, really close to this one, but it's in between which two? It's in between these two, but really close to 35. So it's going to be 34.7, 34.8, 34.9. It's right in between these two, way closer to this one, or quite a bit closer to this one, between 34 and 35. So it's going to be 34 point, maybe 7 or 8. Now let's put it in there. Let's do inverse cosine, sine of 0.57 And we're looking at 34.75 right in there. I'm going to go ahead and put in the full decimal. I could have rounded it to 0.8, but there it is. And that's enough. I'm getting a lot of, I think I'll cut this one off and maybe do the next one.